All right, let's jump right in. Today, we're going to be architects, but not for buildings. We're talking about designing the cloud, building a city in the sky. So let's take a look at the actual blueprint that powers our entire digital world.
You've probably wondered about this, right? How an app can go from just one person using it to a million all at once, without the whole thing just falling apart. It kind of feels like magic, but it's not. It all comes down to architecture. These invisible, incredibly well-planned cities we're building up in the cloud.
Okay, so before we can even start building our city, we got to understand the ground it's built on. And that means looking at this huge shift that made it all possible. We're talking about moving away from actual physical clunky hardware to this new super flexible virtual world. Honestly, this is the core problem the cloud was invented to solve. Just look at the difference here. Back in the day, if you needed, say, 100 servers, you had to go out and buy 100 physical boxes. Can you imagine? It was slow, crazy expensive, and once you bought them, you were stuck. But in the cloud, those same 100 servers can just be little pieces of software running on one giant machine. That's what gives us this incredible elasticity. You can just click a button to scale up or down. And the best part, you only pay for what you're actually using. It's a total game changer.
And you know, it's not just about the servers, it's everything. Thanks to this thing called Network Function Virtualization, or NFV for short, the whole network goes virtual too. The routers, the switches, the firewalls, poof, they're all just software now. And that means we can design and build out our network roads and highways just as easily as we can build our server buildings.
All right, so we have all these amazing virtual tools at our disposal. Where do we even begin? Well, the very first thing you do is stake your claim. You carve out your own private, super secure piece of land. Think of it as your own digital neighborhood.
This space has a name. It's a virtual private cloud, a VPC. And this neighborhood analogy, it's spot on. Imagine this giant sprawling city, right? That's the cloud provider, like Amazon or Google. Your VPC is your own little private, walled-off neighborhood inside that city. It's your isolated slice of heaven where you can build whatever you want, totally separate from everyone else.
So what kind of stuff do we build in our new neighborhood? Well, everything that makes a modern app tick. You've got your web servers, those are like the storefronts that talk to your users. You've got your database servers, kind of like the secure warehouses storing all the important info. Load balancers to direct traffic, and of course all those virtual routers and firewalls we just mentioned. This is literally your application's home.
But here's the thing, a neighborhood that's totally cut off from the rest of the world isn't very useful, is it? Your app has to talk to other apps, and it absolutely has to connect to the internet. So the next step is building the infrastructure, the roads, the bridges, the highways. And this brings up a really critical question. If every single application gets its own private neighborhood, how on earth do they talk to each other, or to the outside world? You can't just have all these isolated islands. The answer? You need gateways. Now for connecting all of your own neighborhoods together, the big kahuna is the transit gateway. Just picture it like a massive central highway system for your entire cloud city. It's the central hub that lets all your different VPCs talk to each other smoothly and, really importantly, securely. And this is basically your entire connection toolkit. To get to the public internet, you build a bridge. That's an internet gateway. What if you need your apps to get updates from the outside world, but you don't want anyone from the outside getting in? Well, for that, you use a NAT gateway. It's like a one-way street. A VPN is that secure private tunnel back to your company's main office. And a VPC endpoint? That's super cool. It's like a private skyway that directly connects your neighborhood to a neighborhood in a totally different cloud provider's city. Pretty powerful stuff.
Okay, so our city is built. The highways are connected. But now comes maybe the most important part of all. Security. How do we make sure only the right people get in? We've got to post some guards at the gates.
Now in the cloud, our guards are called security groups and security lists. Think of them as a virtual firewall. They're the bouncers at the club. They stand at the main gate of your neighborhood, and they can even stand in front of every single building or every single server to check IDs and control who gets in and out.
So how do these guards actually work? It's pretty straightforward, really. A connection request shows up, the virtual guard pulls out its little rulebook and checks three things. What port are they trying to use, what protocol, and where are they coming from, the IP address. A rule might say something like, hey, let anyone in who's trying to access the website on port 443. If the request matches a rule on the list, you're in. If it doesn't, access denied. It's that simple, but it's incredibly powerful and absolutely crucial. But it gets a little more interesting, because security isn't a one-size-fits-all kind of deal. And this leads to a really big design choice you have to make. Do you set up broad patrols that watch over the whole neighborhood, or do you hire a personal bodyguard for every single building? That's the trade-off.
And you can see that trade-off right here. On one hand, you have network security lists. These are like the law of the land. You make one big set of rules that applies to the entire neighborhood, the whole subnet. Super simple to manage. But on the other hand, you have network security groups. These are the personal bodyguards. You can give a unique set of super specific rules to just one server. It gives you absolute granular control. But man, it can get way more complicated to manage.
And that's really the core of it. With more specific control comes a whole lot more work to manage it all. So the real trick, the art of good cloud design, is finding that perfect balance. You start with a simple, broad law of the land, and then you only bring in the personal bodyguards for the really important stuff that absolutely needs it.
So when you step back and look at it, cloud design isn't just about servers and code, is it? It's really about being a city planner for our digital world. It's about building these incredible, resilient, secure, and connected cities in the sky. Cities that can handle whatever we throw at them.
And that really leaves us with one big question to think about, right? As more and more of our lives go digital, what are the cloud cities of the future going to look like? What new kinds of buildings, what new superhighways, and what new security systems will they need? That's the blueprint that digital architects are drawing up as we speak.